want to hand it over to Scott Carlson, who is a security cloud architect at eBay PayPal.
Thank you very much. So I don't kick it over. Hey everybody, where did it go? There we go. My name is Scott Carlson, and I'm one of the architects at PayPal responsible for our OpenStack implementation. Right now I'm focused on security, but over the last 2 years I've worked with the team to build out our OpenStack cloud and design many of the blueprints that are in place over there. So I hope everybody in the room understands who PayPal is, but there's a couple of very specific things I want you to pay attention to as we go through why we would do this in the first place. The first thing is that we're global, and we're pretty large. 140 million plus accounts, lots of countries, and we have products that are growing around the globe, either through self-development or through purchasing other companies that already have technology. We have mobile billing in Latin America, we have a chip and PIN in the UK, PayPal here in Japan. We announced PayPal Beacon, which is a Bluetooth point of sale. So we innovate around the world, and we purchase companies who innovate around the world. And right now we're the largest digital wallet. So what does that mean, right? PayPal is about changing how people think about paying, right? The loyalty programs, sending money to your friends, splitting the bill, compare in store. We are part of eBay. I don't know if everybody knows that eBay owns PayPal, but we have the Red Laser app, for instance, and you can compare the price right there in the store. You could buy that from a merchant and pay with PayPal on the spot if you wanted. So we integrate all those technologies together so that we can enable the consumer to go quick, to keep all their money in one spot in the digital wallet, and then maintain all these things together as they sort of go around. We also are bringing some of our technologies to point of sale. If you go to stores like Home Depot, GNC, I think Office Max, Radio Shack, you can pay with PayPal right as you're checking out. Punch in your mobile phone number, punch in your PIN, walk out, you get a receipt emailed to you, it takes about 5 seconds. So what do we care about, right? This is kind of the why. Why would PayPal do this? We need to enable our business to go really, really fast. Anybody who pays attention to the mobile sort of startup business, to the payment startup business, know that there are people cropping up all over the time, and they're going very fast, right? All the taxis sometimes have pay in the taxi now, not just a credit card machine anymore. We need to have our business decide that there's a new market that they want to get into. They want to take a team of developers, you know, the DevOps sort of thing. They want to concoct that product and put it in production. We've been quoted as saying that we have this 15-minute rule that we're trying to get to, where a brand new developer that we bring in off the street, specifically we're trying to apply to Kraken and the new Node.js sort of framework that we're publishing. We want them to go from code to production in 15 minutes. And that means they push it, they get their VM, the firewalls are up, the load balancers are up, and they're taking traffic, doing some cool new thing for PayPal in 15 minutes. We have proven that it can work. Now we just have to enable the business to do that. We've told the story at some of our past conferences where we actually analyzed part of the workflow of how you used to do business at PayPal. In 2011 and before, we'll call it like summer 2011, PayPal was 100% physical. We had no virtualization at all inside of PayPal. And in order to get a new service into production, it took around 170 tickets in our sort of customized remedy system. Physical firewalls, you had to buy servers, probably bought the wrong servers, then you had to put the SAN adapter in it, et cetera, right? All that standard core IT stuff. And so sometimes it would take 6 months for somebody to get something in production in our legacy PayPal environment. We have changed that a lot. Now with our new model, we can actually self-service all of our tickets if you go into our automated OpenStack environment. And we seriously have moved it from 6 months down to our current SLA is 7 days. which includes making it all the way through a QA, getting put in our open capacity in our cloud and production, and being live in front of customers, which is a huge win for the business, and they've really seen a lot of areas where they have taken advantage of that. A couple recent examples, I think, is the PayPal and eBay app was on the home screen when the Microsoft Surface 2 was released. And in order to get that application built and on that, they had just a few hours, few days from the time that was announced to the time we put it there. And so they used some of this new methodology to get that in place. So people at PayPal, in order to fix this problem, our CIO at the time thought we needed a cloud, right? We can do this with a cloud. We want to set ourselves apart as a leading engineering company. So why don't we go ahead and build a cloud that does everything our developers and engineers want to do? And let's build it ourselves, right? We're in Silicon Valley, eBay, PayPal, very large. We have 6 digits worth of machines now, over 100,000, I think, if you add them all up. And we have the engineering prowess to build a customized environment that does what we need, and we have the people to build it pretty fast. So why did we go down this path? We kind of had 3 guiding principles here, right? I think everybody goes through a thought process like this when they pick some technology. But this was ours, right? We didn't want lock-in, right? We talked about this before, and it's been all over the press. eBay and VMware and PayPal and VMware are OpenStack. We've talked at all the conferences now, and so this is widely known. But we didn't want to be locked in, right? We have enough unique portions of our business that we cannot rely on a feature request to move forward. We have multiple availability zones and multiple globes, and if your product doesn't do that, I can't customize it to do that. So I couldn't stick with vendor lock-in. We have a big project at eBay. It's called One Cloud. We want to combine all of the smarts of all of our companies so that we can actually have a ubiquitous cloud that any owned entity, any Inc. property could actually go in that part of the cloud. Can we do that as one company rather than having an eBay cloud and a PayPal cloud and an X.commerce cloud, etc.? We don't need 3 anymore. We really just need one that does what all of our adjacencies need. And let's go open source, right? Like I said again, we want to prove that we're one of the engineering leaders in this space. We've released Kraken back. We've contributed back to the community much of our open source code that we've released recently. So let's do this open source so that we can make enterprises better throughout and use our scale and our global nature to make everybody better. We picked OpenStack. Our first implementation of OpenStack went live in December of 2011, on a couple of racks. We rolled it out in about 8 weeks from start to finish, and it was a couple of nodes taking production traffic. So OpenStack was one of those things where we felt that we could come early to the game. It was open source, not locked in, but yet it was starting to get the following of everybody in every industry that we pretty much already owned a piece of hardware from. It's not like a commercial off-the-shelf thing, and because it had the backing of all these major companies, we didn't feel that it was, some cheap alternative. We didn't just go buy, Scott Stack, download that and hope to customize it ourselves. We didn't want that. We wanted something that everybody was going to be on board with, kind of following the Linux sort of bandwagon, to help make it more mature. The interesting thing about going with OpenStack is that it's been around really only a few years, but it's one of the things, one of the projects that has gained the most third-party, most company support in such a short period of time. Jonathan showed the slide with the code contributions, and what that shows to me is people are really paying attention. They want to build all these modules that companies like mine can use to make their enterprise better. We follow the building block concept inside of PayPal. I'll talk a little bit about this and how we work with our vendors. We really want to, like I said, enable every piece of our business to use this once we get it going the way we want. Some of the vendors that I put on this slide are people that I have worked with directly to take technology that we already owned, get them more involved with OpenStack community, and deliver the capabilities that we needed to put their product that I already owned inside of my OpenStack cloud without rebuying something new. I'll just pick on NetApp here for a minute. We, as well as many other people, have a significant investment in NetApp already. It sure would be a shame to have to throw something away just because you want to use it under your cloud. What's really great about these vendors is they have all ponied up lots and lots of people and lots of code to make sure that when you call out to Cinder drivers or Nova drivers, or let's see, compute, and we have some storage, and we have some OSs, and we have virtual networking, SSDs, network layer. I just want to call the APIs that come with OpenStack that maybe I've tweaked a little bit, and I want it to work on these technologies. I don't want to have to buy something that supports OpenStack. I want these vendors to say, yep, I got it, right? I met with the community, and I contributed the code so that my Arista switch, so you can just change a VLAN by sending in the right feature code. And so it's very important that I didn't need to rebuy anything. Maybe I needed to do a firmware upgrade, or, you know, in the case of NetApp, again, I picked on them. You have to have a C mode cluster in a certain config to call the Cinder driver. But that was a lot easier for me to do than go buy a new storage vendor. Open NetApp, we'll call it. I think if I were to look at every vendor in my stack that I have built OpenStack on top of, and like at eBay and PayPal, I think we're north of 30,000 cores now under our OpenStack install, about to be much larger. Every vendor in my stack has promised and is doing OpenStack coding and contributing back their drivers to the community. Some of them, even like Dell and HP, have started projects of their own to make everybody's stuff better. So this talk is a little bit about what the software-defined data center means to PayPal. I touched on it a little bit before, but I can't wait for physical things to happen anymore. So to me, the software-defined data center really is about not having to do physical work. And it also means that I have to do things where I do them in my cloud, right? Because that's what I decided I'm doing in the cloud. I'm not quite so sure about virtualizing everything. We heard some talks yesterday about reasons why you may not want to virtualize it, but you may want to containerize it. And there actually is the concept of cloud-based physical gear, in a sense. Some work just runs better on bare metal. There's no reason I can't stick in the cloud. And I have an elastic scale problem. I think most people from the US understand Cyber Monday and Black Friday. If you take a look at PayPal and eBay, our traffic volume, January through March is kind of low. People are out of money. And then as the year goes on, it sort of trends up. And then on Black Friday, it's a hockey stick. And that continues over to the last shipping day before Christmas, right? It's like December 19th or something this last year. That's the last day you can ship something for free that it'll still get there by Christmas. That's historically one of our busiest days of the year. And so there's really no reason why I need to go spend, $100 million to plan for that one day where my traffic is 800% more than my previous days. Like a lot of retail, I need to scale to that. And we are building the capabilities inside of PayPal right now to use things like Heat and Salometer to scale my workload as pools together so that it can just ramp up. The traffic starts getting bigger, it just adds a couple of nodes to the load balancer. I do have to have things pre-built a little bit, but there's no reason I can't triple the size of my infrastructure just without human intervention, because it's a repeatable pattern. I know I just need to go from 100 to 400, and I just let the little engines do it. Like I talked about before, our customer experiences is what matters to us. We've reskinned PayPal.com recently. It's about the consumer and the customer. And if you take a look at that experience, making your life easy to pay and making it secure is something that we really care about. But we want to separate that from what's at the core of our data center. Like many companies that have been around for 10 years or so, we have some big Oracle databases on some big iron, and those aren't going anywhere. And sticking them in my cloud is challenging. But if you take a look at like the standard 3-tier architecture, right? Web, mid, core. I can just let my core stuff sit back there. And I can let the people who do big IBM, big Sun, deal with those in their really scary change management processes. But all this stuff out here that can be serviced, that can turn into an API and can turn into a middleware, I can go really fast in all that. As long as I have enough control so that I don't overrun my back end, I can really enable my developers just go do whatever they want as long as they use my common services. I am starting to show that I can reduce the cost per transaction, which is the business really likes. It costs me, X pennies to make $1. PayPal makes money by a bunch of different ways. One of them is through the fees that we charge on some transactions. And so it matters to our margins how expensive the infrastructure is. As we take a look at our hyperscale, scale-out infrastructure, we're a big consumer of hyperscale product. And if you don't know what that is, it's like 96 servers in a rack from people like HP and Dell. And we just have rows and rows of those. And it's the cattle puppies sort of concept, right? We build a whole lot of one thing, spread it across a rack. So if a server or a rack dies, I really just don't care because I have 10,000 of them. If 100 die, I don't care. I just spin up 100 more somewhere else. Luckily, my scale is such that I can get away with that. And so one of our mantras internally is you have to turn it to stateless. I do have some vBlocks, and I have a bunch of VMware, and I have a bunch of Sun that do my stateful workloads that need to stay stateful. But everything that can turn stateless, I can stick it in here and make it really cheap, or cheaper. My focus area, like I said, is security now. We, of course, need to be PCI compliant, like many other people, banks, financial institutions, other retailers. So we need to do everything we do in the cloud space securely in our PCI zone. And so we've ramped up our security focus as well as our one company initiatives. So what we're doing sort of going forward here as eBay Inc. and PayPal is we're really trying to focus on our own internal private concept of multi-tenancy. And what that means to me is I need to find a way to have every eBay adjacency, every PayPal adjacency live in the same cloud securely and still meet all the regulations that I need to meet. Pick on the colors here. So blue could be something like StubHub, which eBay owns. B could be PayPal. And C could be the PayPal PCI zone. So I want those to live together on the same piece of hardware, underneath the same Ubuntu or Red Hat, on KVM. And I want to virtually separate everything with firewalls that have passed compliance, load balancers which have passed compliance, and I want to spin them up dynamically. If B needs to move to another data center, I'll just shut it down and move it, rebuild it again. So this is our focus area now. So a software-defined data center to me is this: a multi-tenant cloud that has a highly secure sort of management backplane that meets or exceeds all of my security requirements for my most secure tenant that I'm going to put on it. So if I pick on PCI, right, it might not be the most secure requirement in the world, but if I say my infrastructure has to meet or exceed PCI so that it can manage a PCI tenant, so you have to do that in PCI DSS 3 now, and everything that manages you must also be compliant. Then I essentially can say A can be, internet facing if it wants. As long as I bound it and firewall it off and VLAN it off, I should be able to go forward with this. And so this is where we're trying to go. This is what one cloud means to us and what we're working on OpenStack to do, right? Take this and put it in 3, 5, 10 data centers, build it on the fly, use all the OpenStack features, concepts of multiple availability zones, multiple hypervisors, multiple host aggregates, all doing different things. And this is where we get to our software-defined data center, which uses all of these features that we're helping to build inside of OpenStack. This might be hard to read in the back, couple of 4 key areas that we're getting out of this. One of them is the whole stranded compute thing. As a hyperscale customer, I buy things 2,000 cores at a time. So there's like 1,960 cores in a rack, physical cores. And I buy a whole bunch of them at a time and stripe them out. I used to be in charge of buying the compute hardware. I hate buying a whole rack and needing 4 blades out of it because my management zone needed a little bit more. In the past, where I had to cable that top of rack switch to a segment, I essentially had, $500,000 worth of gear sitting there waiting for somebody to use it. So that goes away. My compute silos go away because I can take any piece of hardware, make it in any zone, and build on top of it. I can do dynamic network isolation. Anybody who's ever tried to make a data center compliant, that's been there for a long time, knows that things tend to get lumped together if you don't know what to do with it. So you end up with production. And production has 10,000 machines in it, all with different qualities. And if you do things like start taking credit cards, all of a sudden your entire production zone is in scope for audit because it's all plugged together with no separation. And so what this software defining concept does for me is it allows me to build a little virtual box around the thing that I really need to make compliant, and I can just sort of ignore the rest, in quotes, and only raise my level of security on that stuff that I absolutely have to, and then I can bring that other stuff along later when I build my best practices on the stuff that I have to control. Flexible network, some things in our environment, I'll assume people understand the concept of bridge network versus overlay network, maybe a bad assumption, but some things need to have an IP address that looks like it's on the internet. Other things can be NATed, 192.168.1.1 like at your house. So we have some things that need to know what the IP address of our customer is, so we can do fraud detection. Standard concept, people have started to see it on their iPads. We are detecting that you're coming from an IP address that we've never seen before. Please answer these extra little questions so that we can make sure it's you. So we need to know that kind of stuff too. So whenever we build a VM that has those kind of requirements, we give it a regular IP address. Other things in QA, I don't really care, right? Give it a 10 dot. It needs to talk to the little database I just spun up, and we can do a little virtual network inside of that bubble. And then I can follow a service-oriented approach. My developers are building services, the as-a-service problem, right? We have logging as a service and database as a service. We have everything as a service that is getting ramped up right now. We are attempting to build sort of a PayPal as a service thing for various portions of our companies. If we want to, say, put a PayPal payment engine in some country that it's not in, theoretically, I just need to take the important bits, build them together in a little cloud, and then I can put it in country. And so as long as I build the important parts as a service, and they're really business services as a service, fraud as a service, for instance, then I can go put PayPal anywhere that I need to. I can go put eBay anywhere where I need to. So what have I learned? What have we learned from all of this? I've learned that developers want an application that works when it's done. It's pretty easy to give somebody a VM that is built off your gold image that they can log into and do stuff. That's table stakes now. It's tougher in an environment like ours to also give them all the rules that they need and put them in a load balancer where the pool may not have existed before they concocted their new, pay with clicker app. So what we have built for them, because they wanted this, is, we roll an OS, we certify an OS. We've built our own and worked with the community to build load balancers as a service and firewalls as a service. So seriously, today, on our load balancer environment, if you want a new pool, you just define it in the GUI, and when you're done, you will have a pool created with your nodes in it that is for your new application. We're also playing with PaaS, which is interesting to me in a number of ways with security because, in my opinion, so this is Scott's opinion, some of these PaaS vendors are still at the very early adopter stage, and they haven't quite figured out what high available architecture means and what secure architecture means. So if you're trying to take one PaaS and deploy it into multiple different types of zones, and you need multiple data center security and scale out, it's not quite all the way there yet. So if I were to take this first bullet and have my developer want their Node.js tweak with a bunch of PayPal services and maybe a little database. Today I have to bury a PaaS layer inside of the zone because I break my security model by calling outside of the zone to where they put the PaaS when they rolled it out the first time. And that's a really interesting sort of problem that we're trying to work through is what as-a-service services do I have to put at the trusted hypervisor layer, and which ones do I need to put in the tenant space? Puppet is a really good example of this. Chef, all these configuration management tools. If I use one of those to configure my hypervisor, so I build my hardware and I use it to manipulate the hardware, then I do it again and I do it to manipulate the hypervisor. Can I use that same Puppet instance, Chef instance, to also manage my tenant space? Should I? I can, but should I? Probably not if you follow all the rules of, calling in and out of a more secure zone to a least secure zone. And so when you start to build these patterns, you end up with a config manage instance for your trusted zone, and then individual instances inside of every tenant, inside of every data center, because you can't break your rules of availability by putting it outside your data center. So if you have 5 data centers with 5 tenants, you end up with 15, 18 installations of something just to manage it all. And so that's some of the areas where we really need to focus on to get all this stuff to work together safely. We've really learned that our vendors care to work with us. I'm lucky enough to have scale, so vendors like to work with us. But they are really legitimately trying hard. They're going to all the conferences, they're getting involved as core code contributors, and they're actually building their products. And I've actually seen in the last maybe 6-8 months where we don't even have to ask anymore if they're going to support OpenStack, because they've put it on their data sheet now. And they come to us and say, yes, we have a Cinder API, and we have a Neutron API, and it'll work out of the box to do these 7 or 10 things. And we're actually, we did a real TCO. We're actually proving that we don't need to buy converged infrastructure vendor X or build a huge SAN fabric with a big Hitachi on the back end just to deliver a cloud anymore. We're legitimately impacting the business bottom line. We've learned that we can actually do that. The tough one on the human side of it, right? This has been non-trivial to actually find people who can code at the enterprise level, on a new thing. So over the last 2.5 years, since we've started hiring Python developers, it's been hard, honestly, to find some, again, sort of Scott's opinion on this. Early on it was, let's find people who know Python, and then we'll teach them OpenStack. And then it was, well, these people who knew Python don't know anything about a big company. And so they can't do a multi-availability zone deployment of a load balancer as a service because they've never even seen an F5 load balancer before. They're a Python guy. And over the last 2.5 years, it's been hard to find the talent, and now everybody wants the talent, so it's getting harder to find the right person that you need. But we've been lucky enough to find people in all the core spaces that we need who we could augment with our 10-year data center people. I've been doing this sort of thing for 15 years myself at a lot of Fortune 500, so I can explain to somebody what a load balancer needs to do. I've never written a code of Python, a line of Python in my life, and so they can translate it into Python. So the challenge here has been for us on the human side is finding the right people who like each other, who want to work on those teams. Because the thing with OpenStack is you can't just have a couple of people who don't want to work together. We have a lot of Skype chats and a lot of IRC chats internally where all these people work together to deliver these services. And we have found that by following sort of the blueprint methodology, we certify it internally, we fight it out in a conference room, then we go forward and conquer. We can successfully do all of our coding with people we bring in. We have people in Russia now, in China, all across the US that contribute all together without being in the same place. Let's see. Software-defined everything I don't think is ever a reality. because there are special purpose appliances that just always need to be special purpose. One of the more interesting ones to me that I've just started looking at is the concept of a hardware security module that is required to take credit cards. HSM as a service is probably never going to happen because it's got a little physical card that sticks in it and it's got to hang on an out-of-band network. But maybe the API can be software, but all the rest of the hardware has to be physical and it has to be in the right places. So I can go to a minimum rack footprint, right? A whole bunch of compute, a bunch of top of rack, a bunch of routing, a bunch of storage, and I can, as a service, configuring that, and then I can, as a service, deploy my business logic. But all those add-in components for DDoS protection and whatnot that go around the layer, until the vendors prove that it's as good virtual as it is physical, it's got to stay physical. And that's the key thing for me now in my security space is you kind of got to prove that the virtual is as good as the physical. And in the case of, I've been looking at firewalls recently, there's lots and lots and lots of literature that shows, like a Cisco firewall is just fine physical. When you virtualize it, well, it means you got to put it on top of a hypervisor. Is the hypervisor secure enough for a secure firewall to live on? As far as I know, there's no NIST standard for virtual firewalls. So I can't just tell my auditor, oh, we configured it according to the NIST standard for virtual firewalls, because nobody's ever written one. So the as a service has got a ways to go because of all of these things that nobody's really ever written the standards for yet, and that we're working on now. Our goal as a business is to lead in the payment space, right? And PayPal is going to remain, Scott's statement, the most secure way to send payments. And our cloud is enabling that, right? Our developers are showing that they can go quick with the development. And as we roll out our Node.js products and our other sort of easy to code, easy to distribute, easy to use a presentation layer on top of, we can scale those out on top of a cloud like this. I think that's it for me. I think we have some time for Q&A if I left time. John, if you want to come back up here and take any questions if anybody has any. But
do you think you could give a rough estimate of the number of people involved since 2011 to build out your cloud stack infrastructure?
Number of people involved to build out our cloud infrastructure. So I can only talk for PayPal. I didn't pay attention to the rest of the entities. I think our team, besides some alternate workforce for a few vendors, we had Morantis in for a little while. I think we had a high water mark of 18. And that's less now, but in our early ramp up, I think we had about that. And those have been consistent. It's been the same people the whole time.
And that's your coding resources, right? That's the people actually.
That included me. I was included in the 18. Yeah.
It's actually that's an interesting question because that's a question that I've heard a lot at different conferences that I go to. Is as people are starting to build out these teams, they wonder, what are the right roles? What's the mix of architect, developer, kind of administrator? Do I have to find DevOps guys? What did the makeup of that 18 look like in terms of roles?
So we had two teams. We had 5 people, I think, on the infrastructure team. 2 architects, engineers like me. I did all the hardware buying, the blueprints, the real core infrastructure data center geek work. And then we had 3 sysadmin types, guys who we poached from elsewhere in PayPal who were really good at the Puppet, the imaging, the Kickstart, all those things to make Linux work really well. LDAP guy, and we had some really three jack of all trades. So we had a 5-person core infrastructure team, and then everybody else was a developer. They either worked with people like storage to get the Cinder working, or they actually contributed back for Nova. They made all the code changes. We ported Netflix's Asgard to OpenStack a while ago, and so they did that work. And so I guess that's about a 3-to-1 ratio, coders to infrastructure people.
That 15 minutes scenario you mentioned earlier, developer speed productivity.
Yep.
Elaborate more by giving us examples.
The 15-minute example. We are working on that specifically with our Kraken. If you guys look up Kraken, K-R-A-K-E-N, I think it's a Node.js framework we contributed to the community a while ago. If you want to use a set of PayPal APIs and write a new Node.js application for a new way to take money. You should be able to, from the point you finish writing it, have it do a CI/CD process in QA and pass against our APIs. That gets, through the code repos, gets synced into production, and then the right person hits the button, and where at that point it does firewall as a service, load balancer as a service, pushes the code VMs to as many as you want in the right data centers, and then makes it live. So the 15 minutes starts from completion of CI/CD till the time you can click on it. We're not counting things like, hey, you have a new domain, PayPalFood.com. It doesn't count any of that stuff, but the act of creating the infrastructure and pushing your code there is where that comes from. And like I said, we still have some change management hoops today, and so it's not fully automated. We're still working on some of the, how do I get something safely from QA into the PCI zone without a human being there? But that's sort of more about what the 15 minutes is about. Yeah.
How does the smaller company implement OpenStack?
How does the smaller company implement OpenStack? Jonathan, you want to go first on this one?
Sure. So I think that you mentioned a little bit earlier that one of the strengths of OpenStack is the number of vendors that are involved, and you see it from the standpoint of these companies like NetApp and SolidFire and Cisco have drivers. But one of the other things, there are a lot of companies who are taking OpenStack and building more packaged versions of it, or doing services and consulting around it. You mentioned that you guys had worked with Mirantis. Mirantis is a company that's worked with a lot of organizations to basically set up an OpenStack environment inside of their team when they don't have 12 or 13 developers to apply to it. So if you're looking to do a private cloud, there are quite a number of options within OpenStack where you can go work with a vendor. And there's a good chance that if you buy hardware of any kind right now, your vendor is probably involved in OpenStack in one way or another and can kind of help you start that process. The other way, too, is there are a number of OpenStack public clouds like the Rackspace Public Cloud, and HP Cloud Services, DreamHost, Interop. A number of companies out there. Those are in the US. There are also a variety of public clouds in Europe and Asia and Australia. So if you're looking at more just from you want to start immediately and not have to have any infrastructure, then there's the public cloud side of it. Yeah. But yeah, I would say that if you're looking to do private cloud, unless you have a team of developers, it's probably better to find somebody who that can work with you. And they have different models too, which I think is something again that's very important with the way that OpenStack is structured. Is you can buy an appliance, for instance, that you put at the top of your rack and you plug your servers into it, and that appliance comes preloaded with OpenStack controllers, and so it can virtualize the servers that are in that rack, and you kind of like get this hardware-software converged solution. Or you can go to someone like Mirantis, who will take your existing hardware and your existing architecture and bring OpenStack inside of it. So it really depends on what your model is, but there's probably an option that you can find who can help you get that done.
Yeah. Let me add one thing to that. I really think it depends on what you want to do with it.
Yeah.
I think today it's becoming almost trivial in nature to build a cloud that will build VMs. So if you just want people to just get a VM really fast, you can get your smart IT guy to go install a distribution of OpenStack, either download it and do it himself, or download one of the Red Hats or any of the. It comes with Ubuntu now, right? And they can just roll that out.
I think when I talk small companies, I'm talking about 100 million, 200 million. They're used to having their own developers. They're used to having, doing the things that an eBay is doing, but obviously on much smaller things. But now we have the resource constraints that you talked about from a smaller perspective, and they're struggling to make that happen. So yes, they can go spend a lot of money with the Mirantis or Mirantis and that kind of thing, but they really don't want to. So they're really struggling with how to adopt something like that.
Yeah. I think one of the other comments, so OpenStack can be customized however you want it to be customized, but you don't actually have to. There's a lot of cool stuff in Havana and Icehouse that you can just use. And so if you want to start your curve by just using the cool things that a lot of us have spent a couple of years building, then you might not need all those people to customize it, because these companies maybe only have 2 data centers and they don't need to sync too much, and that kind of just works now. So I think
that's a good point.
It depends on how far you want to go.
A lot of times we do talk about the high-scale examples of it. Tim Bell actually tweeted, somebody tweeted something about CERN, and he tweeted back that they're actually at 100,000 cores now. So they're twice as big as what I said. I can't keep up with them. But, and we talk about those because those are cool use cases. But we actually have, hundreds of OpenStack deployments that are in the dozens of servers range. So there are a lot of people who are taking, it's included in all of the major Linux distributions. So if you're using SUSE or Red Hat or Ubuntu or Debian, there are OpenStack packages that are there. And they're not necessarily going to be custom fit to what your organization needs to do, but if you are on the smaller end of the infrastructure side of things and you want to just get started with automating some of the deployment, doing some self-service to your, within your organization, resource tracking, chargeback, showback, whatever, like just some of those basic things, all of that's pretty much there in those standard distributions.
Anybody else before lunch? We'll go back here in the black.
Can you give us a preview of what's coming up in Icehouse?
Icehouse preview.
Icehouse. So Icehouse, we do releases every 6 months, and they have code names that go alphabetically. So Icehouse is our release that is about to come out in a couple of weeks. I mentioned Federation. Identity Federation was one of the big releases, or the big features in this release. This release is, I think, it really shows that OpenStack overall is moving more from kind of a feature-driven piece of software to something that's been in operation now for well over a year at a lot of places. And so the releases have been much more about stability and ease of operations. I think one of the biggest things that is maybe not like a super sexy bullet point, but the upgrades from Havana to Icehouse are really smooth, and you can basically do full rolling upgrades with no downtime of any of the services that are running on top of your OpenStack environment. So that's pretty big, and we've already had some users who have done that on very large environments. I think it's a lot of good work from an operations perspective. There was another.
So the question is, are we running real transactions on this? Yes. So as we've announced in the past, about 20% of PayPal, real production PayPal.com runs across OpenStack. The compliance is maybe not something I'll answer directly, but there you can apply existing control things to OpenStack just like anything else, right? You can patch it on a cycle, you can build a process, you can harden your firewalls that are on the outside. And as long as you follow the older best practices and show your work, you can get to what you need to do inside of your already compliant data center. Okay. Anybody else?
What do you think the biggest hindrances to adoption are, and then when you kind of see any inflection points across the bigger, the broader market?
The biggest hindrances to adoption across the broader market.
Well, I think that you touched on a couple of them. I think the talent that is actually something that I've heard from a lot of people is just being able to find the right skill set for whether it's OpenStack or cloud in general. Just that there's kind of a shift in thinking both how to run it and how to use it. So I think that that's one of the things that will cause an inflection point. With OpenStack specifically, I think that kind of what we were talking about over here, just the understanding the right path for a specific organization to get to a useful cloud running OpenStack. There's so many different ways that you can take, and it really depends on what you want to do with it and what your organization looks like, the kind of resources you have. I think that the technology is there now. It's more about understanding how to navigate it. And from the foundation perspective, this is actually one of our top priorities for this year. We're going to be rolling out some some new services and kind of a framework to try to help with this in the next couple of months. So I hope that will be one of the inflection points. But I think that there's from people who have been able to get through, like Scott and his team at PayPal, get through to that point where they have a useful cloud. At this point, a lot of them are not complaining anymore about technology. It's about like the people and the processes and kind of the culture inside of their organization of figuring out how to navigate the softer things than the hard tech itself.
Yeah, and to add on top of that, I have some friends in some large financial companies, and they want to buy something so they can blame somebody, those companies. And I don't know that, we're just starting to be able to buy OpenStack from IBM, for instance, right? So you can blame IBM then, I guess, if it doesn't work. And so these corporate politics, I'll call them, you have to be willing to increase your level of risk tolerance to go down this path. Because it may not work, and then you could go fix it or you could wait. But then
so you blame as a service, basically.
Yeah, who you blame as a service, I like that. And then the vendor ecosystem. People have blamed the vendor ecosystem to me, right? Companies like VMware have had their vendor ecosystem in place for a very long time now, and everybody knows this. The ecosystem is just now starting to get press that they're behind it. But I'll say it like this. Your average middle IT manager doesn't know that. They were at VMworld one time, they were at so-and-so, they went to a movie with NetApp or whatever, and they learned about how VMware plugs into blah, blah, blah with the module of the blah, blah, blah. Right, so that whole perception is still, I think, heavily weighted in this sort of old school IT, and is just now starting to compensate on this other side. So it's very fluffy in nature, but a lot of opinion driven. Mostly opinion now than technology.
I'm so excited that we got some questions. This is great. Any other ones?
How are you doing network virtualization?
We're in a Sierra shop, and if you want more information than that, we can go have a conversation about that. Anybody else? All right, thanks, folks. We'll be around.
Thank you.